OK。参加したい人はみんな来てますかね ?OK。So one request from me that Chia shared his Google Colab notebook, but to work like to continue the tutorial, you need to copy the notebook on your own Google Drive. そのまま使えないので、Google コラボは、チアがシェアした Google コラボのファイルは、そのまま使えないので、ファイルのところで、自分のドライブに保存というのがあるので、そこにコピーを作って、自分のコピーで、自分のコピーを使っててください。OK。じゃあ、みんなできたら、やりましょう。チア、よろしくお願いします。
Okay, so I shall start now. Okay, so first for Google Colab, so you just go into, you can just Google Colab, yeah, and choose the first one. So at here you can use the new notebook. Yeah, this is how you create a new Google Colab notebook. So from here, you can see the runtime and the change runtime type. So we are using Python 3. So for the hardware, we can choose the GPU, but the free GPU provided here is only until 12 GB. Okay. So I will continue in my Google Colab. So the runtime here is the same. So, but first the runtime is totally clean. So we need to start by installing some libraries. So in here with this exclamation mark, yeah, it will run the line as your command line. So here we will start by using the pip here to install transformers and the dataset library and the sentence pieces which will be used by the modulator, and also the accelerate which is also will be used by the modulator. So okay, we'll run them now. Okay, so once it's done, if you have file in your Google Drive, you can actually use the code here to mount your Google Drive, which is the drive of your currently logged in account. Yeah. So connect. Okay, so once connected, it's in your file. This file, the third button over here, is in the content. Yes, you can see your drive. This one is the mounted drive. Yeah, everything is here. But if you want to upload your own data set, for example, I have this data set with 10 data from Chinese to English. So I save this data as CSV. So download as comma separated value.
Oh, so sorry, can we, because I think I'm already lost. So I connected to my Google Drive,
Okay.
and it's in the content and
Yeah.
drive, right?
Yeah.
And in my drive, there should be the data that I'm using.
Yeah.
Okay. So now I need to take this small data set that you prepared and put it in my drive, right?
Yeah, but actually I use another way.
Okay.
So I download this data, so it's in my download folder now, this one.
The test CSV.
Yeah. So I save it as test CSV. So you can actually just drag and drop into content.
Where is the data set? So I think we don't have the access to this.
Okay. So you can download this also. Oh yeah, sorry.
Okay.
Okay, I will share the link in the channel.
Is this the correct link?
Oh yeah, so it's on the third sheet. Okay.
Okay, the last sheet. Okay.
Okay, so we only have one sheet now.
Okay.
Okay, so yes, we can download this. So the two most common used format is the CSV and the TSV. So the difference between this is that one is separated by comma and one is just by the tab. So we save this as comma here. Okay. So now we have the test CSV in your download folder. Okay, so you can drag and drop into content.
Content or drive?
Content.
Content.
Yeah. Okay, so next we start importing libraries which you will use. So mostly we will need TensorFlow. So we import as TF. Also pandas is for reading the data set. So and the remaining, so we just run all of them. Also from this one is we import them from the library transformer we installed just now. Since we are going to use model for sequence to sequence. So these are the things we will install, especially the auto model for sequence to sequence.
Hey, is everyone following?
Not exactly.
Okay.
Yeah,
So,
any question?
I'm getting the data set up real quick.
Okay.
I can't find content.
okay, you have to click on the dot.
Yeah.
On the top of the right? Okay. Okay, you don't content.
Yeah.
Yeah. That's it. You just have to put the file in the content folder.
Okay.
You just drag and drop it.
Okay.
Okay, so next we will check the version of our TensorFlow and our torch and our transformer with this code. So one important thing here is the version of the torch and this one, the CUDA. So because for different GPU, that you will need like different version of this. So it depends on how you install them. So but in this runtime, it automatically install the one which will be like compatible to the GPU here. So it's okay now. So for this code, we can use this code to check what kind of physical device you are currently connected. So you can see we have one CPU here and the GPU here. So only one, because it's only show like one of these. Also for using the GPU to run thing, you will need the CUDA from the torch. So we can make sure if it's installed correctly with this code. Yeah, so true. So yes, it is available now. Okay, so anyone have any question? Okay, so next we'll start the code from the Hugging Face. So these are actually the code provided. So you first, for training something, you will need a model and a tokenizer to tokenize your data. So for the model, we will use the library we installed from Transformer just now, the auto model, to choose. Yeah. So this model checkpoint is the name for this. So we can Google Hugging Face. But yes. So since I'm using the large 50, this one. Okay. So for using any model in Hugging Face, you will need this, the name of, and then the path of the whole thing. So Facebook, and so this model is from Facebook, so it is stored directly under Facebook. Okay, so this is the whole thing. Okay.
Right. So if I want to use a different model, I just change this name.
Yeah.
And it should work.
But because we are using auto model for sequence to sequence, so this is mostly tuned for like model which are for sequence to sequence. Yeah. Okay. So since the embed is text to text generation, so it's actually sequence to sequence. So we just run it. Okay. So if you download the model into your computer, I mean the Colab. So after it's done, we can check the tokenizer, because different tokenizer have different setting. Okay. Okay, so you can see, because it's many to many, so we can actually choose from many language to translate to many language. So to choose them, so we can see now from the tokenizer, these are all the language available. Also, I think these are the new language or some updated language. Yeah. So next, so one of the parameter provided by the tokenizer is the choosing your source language. Every tokenizer is different, but this one, because it's many to many, you can choose your source language and your target language. since our data is, we are going to translate from Chinese to English. So we'll set it to Chinese to English. Yeah, I mean, the language code is listed in the tokenizer list. Yeah. Okay.
So I have actually one question. Okay. So the model is in general text to text, right? Or sequence to sequence.
Yeah.
But it assumes that it's from language to language.
Yeah.
So I have to choose some specific language, right? What if I want to just do some kind of sequence to some kind of sequence? So for example, I don't know, trying to encode something, or just like in Sakai's research, when I'm trying to decode or encode kaomoji, right? Face marks.
Yeah.
Or when I'm doing something that is not specifically language. Should I choose, for example, if it's kaomoji in Japanese, should I just choose Japanese to Japanese, or is there some like general sequence tag?
Yeah, good question. But I think if you are translating them into Japanese emoji, then I think you should just choose as Japanese.
Okay.
Yeah.
And also, I see that Japanese. Oh no, so we're working on Chinese and English.
Yeah.
So so there are no multiple versions of Chinese or English, but do you know if there is any meaning in the XX category? So the Chinese is like ZH and then CN, right?
Yeah.
And then you have, for example, French, and it's XX, and Japanese, it also has XX, English XX. Can you say, do you know why it's like that?
Is it maybe combining several countries, for example, US and England?
Yeah, that's what I thought. And so I guess in Japanese that would mean that they sort of divide Japanese into Tokyo dialect and, for example, Osaka dialect or something like that, right?
Yeah.
Okay.
Yeah. So for this language code, so from what I learned last time is the first part is the language, the name of the language, and the second part is the country.
Oh, okay.
So since English is universal, so I think they just use XX, and I mean only Japan speak Japanese, so it's maybe they know it here. They no need to like specify Japan, but for example, TA for Tamil is from India, so they read right here. Yeah, and ZH is from China, so this is actually Zhongwen. So yeah.
Yeah, I've seen the language country format used a lot in web development. It's used to specify regions and languages. I've just never seen the X's.
Okay. So if you are doing research, for example, summarizing a paragraph into a sentence, since both are English, you can actually choose both source and target as English. So it will mainly focus on the pre-trained language. Okay, so next, to read your data, since we will be using the Panda to read the CSV. So this is the function here, the code. So for the first input is our file name. Yeah, since it's a CSV, the delimiter which separate between the value, so it's a comma because it's comma separated value. So if you are using TSV, so this one here will be the tab. Yeah, something like this. But we will be using comma. Okay. So since okay, so for since our data, the first line of our data set is just the label for Okay, sorry, let us continue. So since we will not be using the first line, the first row, so we will just keep it here. So since we already skip it, so we assume that there's no more header. So now to define the names in my data, so since we are using the CN and the EN, so we just use it here. Also for the data type, both are string, so this is how you set it up. Okay. So my data will be like this.
今の時点でみんなフォローしてますか？問題ないですか？エラー出たりしたんですか？
今まで大丈夫です。
エラー、そう、エラー出た人はもう今の時点で。そう。
エラー出たらすぐ。エラー。
私も。
じゃあ
やってない。PD。
So you run everything?
Ah.
Because everything needs to be run. You run.
One by one.
Yes.
これ同じ。
自分のやつでやった時なんですけど。そうかね。これって、このままで大丈夫ですかね。こういうふうに。
この絵文字は多分日本語だけの絵文字だから、両方も J、そう。
ありがとうございます。
Have you run everything from before?
Yeah.
Let's check.
Maybe
Like every part has to be run separately, right? So, okay, until here you have everything, right?
いや、でも名前が首パッ
はい
早い。どこだ。これ、変えないし。シャー。なんでコミがあってできるの？
これが違う、もしかして。一緒っていう。
そうなんだ。名前違う。
名前違う。
そっか。これやばい。
Oh, so Nick and Wang, do you have any error or something?
No errors to this point.
Okay. You? Okay.
It's slow.
Okay.
Mhm.
Okay.
Um,
Because with the sheet one, this is only S.CSV, so just name.
okay.
Yeah.
Mm. Okay.
Okay, so when you run my data, the one you just read from the CSV, so it will show it like this. So we have 10 data which start from 0. Okay. So if we check the type of this data, so it is saved as a type of data frame. Okay. So next we will start using the tokenizer. Which has this following attribute. So first, since we have two column in our my data, so first we will store every row in my data, the Chinese. So this is all the data in the Chinese column. So we will make it into list and put it into our tokenizer. Then the output of the tokenizer will be stored into the token CN. So this is the name. So for the English column, we will do the same, but with the English. So this thing here. So actually this thing is, if you run this, it will just show all the data in this specific column. So if you run the whole thing, it will show all the column. So, but with this, you can choose a specific column. Yeah, or even specific line. So number one is, not the first one, but because it start from 0, so number one is this. So that's why this come from this. Yes. So after we put them both into the tokenizer, so now we check the tokenizer. Oh, sorry. Sorry, I mean we will check the data which is processed by the tokenizer. So you can see now it's full of numbers, which is actually there are 3 attributes here. So we can see it's input ID, and the attention mask. So now with both of these, we will create one more final data. So for this final data, we will use the dataset library from Hugging Face, which will make it into a type of dictionary format. So in here, we will have 3 of the attribute here, which is common for most of the sequence to sequence translation and training. So for the first input ID is the one you want to train the model with. So for here, since we will have our model to train from Chinese to English, so our input ID will be the input ID provided from the tokenizer for the Chinese. So and the
Sorry.
attention mask, yes, yeah.
Can you go up a couple instructions? I missed something from 1 or 2 instructions up. Yeah.
This one.
Okay, my data. Okay, I see. I see
Yeah,
now.
these are just showing the data. Yeah, so the next step is actually using the tokenizer for both column of our data. Because we will be translating this into this. So both are needed here. So these two actually is the same thing, but for different column. So this is the CN, and these are the EN.
Okay, I got it. Thank you.
Okay. So for your final data set, so the label is your target language, which the one you want to translate it to. So from here, we will use the input ID from token EN, which is the English data, and this one and the previous two will be using the Chinese data. So we will create our final data. Yes, so our final data will have 3 features, which is the input ID, which means the Chinese text, and the attention mask, which is the mask of the Chinese text, and the label, which is the corresponding English text. So we can check the type. So this is a dataset type. Okay, so the next one, which is setting your training argument. Yeah, we will start the training now. So this thing is provided by Hugging Face. So since we are using the sequence to sequence, so for all the attribute inside, actually there's a lot, but mostly we will use few of these. Sorry. So the first one is the output directory, where you will output your training checkpoint. So do training true. So yes, because we are doing the training. So since we are not doing the evaluation for the training, so we will set it to false. And for the number of training epoch, we will set it to 3, so it will run 3 times. So if we don't know what batch size are we going to use, we can choose auto find batch size. So for the last one, so this one is no CUDA. So if it's true, that means you will use the CPU to run the training. So if you commented it or you set it to false, it will run using CUDA, which you will use the GPU. Okay, so first let us try to use the GPU. Yeah, so this following code is also the staple from Hugging Face to set up your trainer. So your trainer here, you'll be using your model as your model, the training argument you just set up just now as the argument. So for the train data set, we will use the our final data. So since we are not doing evaluation, but they will need you to set up the evaluation data set. So you can just set it as your final data, but it will not be used. So the tokenizer will be your tokenizer, and the data collator will be the data collator you set up. Yes, these are actually the basic structure from the Hugging Face. Okay, so next we will use our trainer.train to start training. It's working. Okay, so the training is now finished. Oh, it worked this time. So we'll use the trainer.save model to save our model we just trained. So it is not the raw model anymore. So we just train them with 10 data. So we can new model. Okay.
Oh, no. Oh, you used your whole RAM. Maybe you got like every time you're using GoogleColab, you get slightly different settings of your computer or virtual computer.
Yeah.
So maybe have less RAM this time, and that's why you didn't have enough RAM to finish.
this, yeah, probably.
But we want to finish the training, so let's actually do this again.
ここ。イングリッシュ使わない場合。丸ごと。
But I think you have to go.
CEO だけど。
あ
あ、まあ、これもう CEO よ。
So, because right now before
自分が作った名前だからなんでもいい。
the computer had like an open line, but you close the line, so you have to go through. But it should be faster.
あ、できた。OK。こっちも。CEO。大丈夫。
大丈夫だね。
え？
時間起きて、上のやつ復興してやるかと思った。上のやつまでやろうっていう。全部。
Muy
Vale. Vale.
Vale.
¿Listo? Ahora, ¿cuándo?
train 的 safe model 是 safe 在哪里？
我该因为这边我 set new output directory，所以呢这边有 content 这边有 new，
哦，可以。
这样呢 new model，
哦，
不是它放它就放这里整个 content new model，整个就是我 save 的。
あ、ここまで来てて、ここでか。ここで
一个他们历史考的，他们是 safe 我这里放一个这样。
哦，你放进那个图片里面。你有猫，你的 drive 就有这样的 receive 过去，对吧？
没房子，
哦，感觉到。
啊，这个，对，对呢，可以。
気をつけてしたら。
ああ、全部で、これはもうしょうがない。
今 sequence to sequence 使ってくるから、これ監視アンスるんじゃなく、これ同じ？
ラムが足りない。
ラムタイプ。そう、毎回のラムが違う。これもこれ5回目。前4回全部ラムタイプ。今回できた。
Okay.
Mm,
So let's look
あ
at
れ、気にしないとダメやし。
So, okay,
Fair.
but look at this one. And also the previous one and the previous one and the previous one. Only those which have been checked.
Oh, Nick, do you have any problem?
Nope.
1 minute ago.
Okay, so
No, okay.
Yeah.
クラッシュ、分享各项2重全部だ。
对。
クラッシュしたら、
let's
全部出す。
try to find it. That's nice.
Oh,
So, one group.
I can check a little bit.
Are you using the like translation of the page?
I didn't mean to, but
Oh, okay, because
yeah, it's no problem.
print it off because it will be
ああ。
yeah. Okay. So is that from the beginning, right? So
Yeah.
okay.
I got
Okay.
it. Я фактически переписывала.
Oh. I think most of them crash. They have to restart the whole thing.
Your
No, them.
forever.
The RAM is.
Oh, the RAM. Oh, okay. あ、みんな、そうか。
気にしてない。
みんな自分のドライブにコピーしましたね。じゃあ、どこに問題があるんでしょ
ちょっと思いまして、今は。
う。
Weird.
Okay, so
That's okay.
Right.
So, sure.
Cool. Okay, so how about if, for example, you have if Google gave you too small GPU, maybe you can train without using GPU. So if you probably go back to the to line number 24. Okay. Okay, this one. Where you have training arcs. So maybe like where do we have training arcs? That's fine. So okay, and you're not using CUDA. Okay, so how about you comment out this line? So you add the hash before it. Don't delete it, just add the hash or the hash before from the beginning of the
This one?
Yes, and now the
One by one again.
Python is not looking at this line. It means that right now it will try to use. No. So before that line, where are we? Did you? Okay, where are we? Right. So if you change this, now you should be able to just run from this place. Okay, but could you click something right now?
No. So again, probably.
Yeah, but
the beginning.
you should be able to run from this place, but okay, let's go back a few places. Okay.
Again.
Oh, so you can train here.
Yeah,
Oh.
it seems like here everything went okay, but we'll see. And of course, you have to wait until once. So this is empty, right? So you don't need to run empty. But something is running, you need to wait until it finishes to create the next point. Okay, very nice. Very nice. Action. Train the first one.
Oh, that's it. Okay.
So I guess the problem here was that you can either use GPU or CPU for training. When you're using GPU, it uses the processors from the GPU and the memory on the GPU. But when you're using the CPU, it will use the CPU and the memory, general memory of the whole space of the whole computer. And the memory of the whole virtual computer is not the same as memory on the GPU. So it's possible that the general memory is small because Google assumes that you will train on GPU because everything is trained on GPU in general. So they make the small space virtual space and just give you a stronger GPU. That's why if you train on CPU, there might be not enough memory or something like that.
酒井さん大丈夫？
今回は
あ、できた。
多分、ステップトレーニングのスキル。
これできたら。大丈夫。
Okay, so I will continue next. So after your training, you can save your model, the one you just train with trainer.save model, and any name you want. So now in your content, you have. Oh, sorry. So now in your content, I just saved my new model as new model 1, 2, 3. So it is now saved in the content folder. So next we will call our new model to run some testing. So new model. So this time we change the name to MC2, and it will be our new model directly from our directory. So done. Okay, so if you succeed in holding your own new model, then we can move to the next step. So for here, we will try to use our model to try to translate our data, which in here we will try to use our model to translate the Chinese part into English. So in this loop here, so we loop every data in my data, the Chinese column. So we use our tokenizer to encode each of the data. Sorry, this is just the naming, so it can be any name. So we encode our data with the tokenizer into input token with the same setting for the text, the padding, the truncation, and max length. So next, we will use our model to generate the input token we just encoded here. Generate into output. We will save the output into outputs. Oh, sorry. One thing from before. So when we call our own train model, so for the model here, we can use the .CUDA. This one is to assign your model into the GPU. So the next text it do will be running using GPU, because we will be running the testing. So it's not the training, which will require a lot of RAM. So mostly in the testing can run in the GPU unless it's some special text. So finally here we will add another .CUDA for the model to generate them back into output. So next we will use our tokenizer again to decode the outputs which generated with our trained model, and we will save them into decoder output. So the whole process here is you use your tokenizer to encode your data into input token. Then you use your model, which you train it with your certain training data. So they have different vocab or knowledge about your task. So with the model, you generate the output using the input token encoded. Then you use the tokenizer to decode again the output which from your model. So in here, so since this is run in the for loop for each of the data, so I append them into a list. So we can see that also run it. Okay, so this is the output from my model. Okay, any problem? This is also the basic structure provided by Hugging Face to use your tokenizer. So it's encode and decode. So there's few way to run this, but for me, I run them like in this for loop. So every time it encode and decode, it run on one data.
Wait, do I have output in Japanese?
Oh,
If you run it right now, it's probably from the previous run. From Chia trying some other stuff. So if you run it right now, you will have the output in English.
oh, hello. So far, anyone have any problem?
It's okay.
So one question. So right now the output one is in the memory, right?
Yeah.
What should I do if I wanted to save it in a file, for example?
Yeah, you can, there's a code. So you can use the Panda to save them. Okay, sorry, let me search for the code.
If you remember.
It's quite long. So
Okay.
let me check my code. So the code I use, so I define a function to save, as the name is save test. So in here, I open a new file in my directory. So this is from the CSV library. So this one is for every data in the list, the output. Let me zoom it. So we store everything into one line and store it to this variable. And then we use the writer, which is also a function from the CSV library, to write it to every row. Then we'll close. Okay, so maybe I will reproduce this now.
Okay.
Okay. So this code is just a simple for loop, which run running according to the length of your output 1 in terms of rows. So then it output every row and write them into your new CSV. So now we store the new CSV in our content tab. So it's like this. So you can actually store your data. So any question? Is it working?
I think so.
So is there like a new CSV in your content folder? The one you save?
Yeah, it's in there.
Okay.
Yeah.
So now you have your own translated data from your model. Now we will try to evaluate them. So here we will install the evaluate library. So then from the evaluate, you just you import the load library, which is used to load your metric. So with this load, you can choose from a variety of matrix provided by Hugging Face. So let us Google it. Yeah, this one. Evaluate metric. So actually have many here. One of the most common is the blue. So how to use the blue. So this is the code. Since we'll use the load to load blue. So now this is the code. Okay. So now my blue. Okay. So from here, the prediction is what your model predicted, which is the data your model output. So for us, it was output 1. And reference is the one you want to refer to for the score. So for us, is inside our original test data. This one. So it's in my data EN. So you can run it. Sorry. So in here, you are comparing with between output 1 and my data EN, which is the one we provided, the English we provided. And output 1 is the one your model translated. And we will store them into a variable. So we can run it to see. Okay, so the score we got here is 0.71. So for here, if we put this, it will put the whole list inside. It's not each of the data, but every one of them. So the result is the average score for all the data. So this is the score we got from comparing the translation from our model, which we just trained, and the gold standard we provided here in the original data.
Oh, we just looked at our new line. Because I think, yeah, here, I'm gonna be here for all. And then just type my result. It will just print the whole content of the whole variable. No, okay. So this is the result for all samples in the test dataset, right?
Yeah.
What if I wanted to see the results only for one sentence?
So for this, you will need to use a for loop.
Okay.
Because the compute and both the prediction and reference, they only take list of lists. So when you use the for loop, you will need to convert each of the data into one whole list. So I had one sample which also used the same. So it's something like this. So in my for loop, I take each of the data, but they are all converted into list itself. So it's the same way you save your data. So now with this, I save each of them into a file.
So for example, I cannot just take one element of the output 1 and one element of my data. So like, I thought it would be easy enough to just add, let's say, output 1, bracket 1, or
yeah, because the metric only like take list of lists.
Oh, okay.
Yeah, so if you want to take only that one, you have to convert them into lists. Yeah.
Oh, so okay. So I just need to make a new list,
Yeah.
which contains this one prediction, and the new list that contains this one reference, and then
Yeah.
compare. Okay. Oh, okay, so that actually should be pretty easy.
Yeah, so for my code here, so I zip both the prediction and reference together, and I have two of the value here, which is both the prediction and reference. So from each row, so which is every single data, and I convert them into the list. Then I compute them with my blue. Then I append them and store them into here. So this one is just another code to store them together like this into a text file. Yeah. Yeah, but most of the matrix actually just give you the average result for every data.
Would it be too problematic if we try to just replicate this right now?
We can try.
Okay.
Let me copy my code. Okay, so in this code, so since we use the output ones and as our prediction, and is my data English as our reference, so I use them again here. So but I zip it and run them in the for loop. So now one is this, the output one is now named as prediction, I mean PRED, and this one is now as REF. So in each of the loop, I compute them one by one, but in here I set them to list so that the compute can accept them. So it's only one data which is stored into the blue 2. So now I append each of the result from the blue 2 into blue 3. So it will run 10 times here because we have 10 data. So now we run blue 3. So now you can see we have 10 result here, which is the individual result from each of the data. So any question?
Precision for school. Precision.
Huh? Yeah.
Yeah. What does mean actually for school?
Yes. So the output value described here in the blue. So precision is list of the means of the precision. Okay. So it's here. Okay. Sorry. So for the result, since there's so many output here in the output value, so if we just want the main blue score, so the thing computed here. So for example, this one. So my result. So we can check the type. So it's a dictionary type. Which means we can take each of these out like this. So if we just want the blue, so we can see all the value inside, we can just output any one of them. So if I write this, it will just output the blue in the whole result. So for the one we want to calculate the individual score, so we can just append this, only the blue. Okay, so now it will become just only the list of all the blue score for each of the data.
Nice.
Okay, so any question? Like,
来ましたか。
Okay.
はい。素晴らしい。じゃあ、これはもう大体これで全部ですね。
Yeah.
Okay. Yeah. So right now you can what you can do with this is that you can first of all change your data set, right, to your own data set. And also you can change the evaluation metrics to any other evaluation metric you want to use, right? And that's basically the basics of the sequence-to-sequence models, right?
Yeah. Okay. So there's a catch. So for example, for your training, so if you are training a lot of data, but if your computer keep crashing, so when you do this, so you can, for example, here we'll use the save strategy. This is in the argument, which we set up all the thing just now. So actually this thing here, there's a lot of things you can set up here. But since most of them are not helping me much, so I just disable all of them. But actually they all have a default value. For example, the learning rate, the default value is the 5 EV minus 5, but you can set it to others. But if you commented it out, it will just use the default value. Yeah, so there's a lot here. So back to just now. So if we enable these save strategy steps, so then if you are, for example, if you are training 5,000 data, and each time it only train one data, so that means one data, one step. So and here, so every 1,000 data, it will save a copy of your model. Like sorry. Ooh. Sorry, a bit like. Yeah, so this is the checkpoint. So since it's saving each of the model, it will the size will be like 2 or 3 gigabyte. So if you save too much, your disk will run out of space. So we can set this up, save total limit 3. So maximum there will be 3 save. If there's more than 3, it will delete the oldest save. So for example here, this is the 3 latest save I have. So even if I stop it halfway and it reached this one, I can continue it. So how to continue the train? Yes. So normally your training, you start, it's just .train, then you start it from the beginning. But if you have checkpoint or something saved, you can just run it. So for example, this is my latest checkpoint. So I can just press it and it will start running again. Sorry, let me check. So 145,000. Okay. So let me try. Okay. Yes, so it will skip all the training it previously did and we'll continue from the latest one. Yeah, that's all.
Awesome.
Yes, so it continues from this. Since this is a lot of data, so you can actually set the step to be lower. So maybe 100 step. But if the data is too much, then it will keep saving. Also saving will take some time. So maybe your whole training will run longer. Yeah, so you can just adjust to your own need. Yeah. Okay, that's all.
Okay, thank you very much. Yay.
Thank you.
Awesome. Okay, thank you. I guess we can turn off the
Okay.
sharing experience. Okay, so Wang, Nick, thanks for joining. Do you have any? Oh, sorry. Do you have any? Oh, okay. I guess you're turned. Okay. Nick.
Yeah.
Maybe not. Okay. So can you hear me?
Yeah, I can hear you.
Oh, sorry. Just. Okay. Once again. So Nick or Wang, can you hear me?
Yes, can you hear me?
Okay. So do you have some other questions?
Not at this point.
Okay.
Yeah,
Okay, great.
I know I'm gonna have to change things up a bit, since there's not going to be an Ainu language in the in most models.
Oh yeah, that's a different story. These are the basics.
Yeah.
Okay, so for now, I guess we can turn off the recording, and we can also turn off the whole meeting. Okay, so thanks everyone for joining.
Thank you.
And see you next time.
All right. See you next time.